Okay, this is the first stream of the Learning Faithfulness project, I guess we'll call it. This is all raw and uncut. It's going to be terrible, but it's going to be good. We're going to learn a lot. Starting with, how does RPC work on Tezos? I don't actually care right now how it works. I just want to know how to debug it, you know, how to not set breakpoints, but like set log messages, that sort of thing. Enough to write code that interacts with it. So I guess we'll start with the Tezos documentation. We will switch over to a different screen. It's getting late, so we're going to use dark mode. RPC. Light mode. I don't think that means what dark mode means. Okay, RPC errors. Index. All right, this is not looking so good so far. All right, let's start with the top one. RPC. This is nothing helpful for me. I mean, like, it's all right, but it doesn't really help me understand how one adds new RPC endpoints. Okay. This is like some generated docs. The errors. Okay. As suspected, we got nothing. So let's peel back a layer. What libraries do we actually use to generate this? I think somebody posted it. Like, oh, let's see. Let's open up VS. Okay, I think this lists dependencies, right? Help. List selections of OPAM packages, currently installed packages. Okay, that's not right. Let's learn how to use like camel dep, maybe? Okay, camel dep. Help. Okay. Generate all dependencies on all files. Modules. What? Okay. How about go to the protocol and we'll run that same thing again. Yeah, this is an accurate portrayal of my day to day. Oh, source files. Let's see. This isn't what I want. I want to like list like I guess we can just go to the OPAM file. Okay. I think it's in the environment. Oh, let's see. RPC. No. RPC. L. Lib Tezos. That doesn't sound right. Lib RPC. Yes. Dune. Data encoding. Resto. I bet that's it. Resto. Hey, it's from Nomadic Labs. That's a good sign. Type safe HTTP JSON RPC is based on the service a la Helium. Okay. Object. All right. Where are the docs? Oh boy. Where are the docs at? Gotta be docs. Give me. Oh. OCaml, Resto, documentation. Hey, look at that. Okay. GitLab, Resto. Oh. Okay. We're just gonna go in there. Oh, let's look at the tests. Okay, this is helpful. This is helpful. Okay, so the ad service, we're gonna assume, oh, it's so dangerous, but we're gonna do it anyway, that if I make a post request to this service once it's up and running with an empty query string, if I give it an integer, it's going to reply with an integer. If I give it something else, it's going to be what? The empty object, the empty JavaScript object? That sounds plausible. Let's see. JSON encoding.empty, an encoding of an camel unit by an empty JSON object. Got him. Okay. Path root / foo. Okay, I'm gonna assume that this is like a, what is it? Infix operator that is like a integer goes in the slot. If I call like foo /1 /add and then I post like 1, it's going to give me 2. Add. All right. I know where this is in Tezos. Or to put it differently, I know where I saw it. Or I know I saw it today, rather. I think I can find it actually pretty quick. Oh, look at that. It's the last thing I searched for. All right, so run code. So, all right, let's compare like with like. See what we got. Run a piece of code in the current context. Query. Empty query string. It takes, some parameters specified by this data encoding, and it returns, actually output encoding. So it's something that we could look at later. And it takes a path, just like hard-coded thing, and then code. So what really confuses me about this is like, where is the function? Where's add handled? So for better searching and et cetera, we are going to we're gonna cd into repos and git clone this thing. I wonder if this will build. I guess we just run what? This looks innocuous enough. Let's cd resto what? opam install dot maybe? Question mark? I don't know. Okay, it's looking good. We're gonna get a new window ready. Connected via SSH to our virtual box. Yum. Then we're gonna open up a folder. Repos. Stow. Okay. Oh, setup not working so great for me. VS Code and VirtualBox really slow. In fact, you know what? I'm gonna use Ubuntu because we have double the cores available to us. So cd repos git clone. Oh, so much faster. Opam install dot. Ooh, opam. Ugh, I just lost whatever speed I gained. What kind of OCaml compiler do you want? Opam switch create 411 opam and opam install dot. I don't know how to use the Tezos switch, but anyway, let's just keep looking. All right, let's do the test. All right, so we did easy services.ml here. Like, am I missing? Is it right in front of me? No, this is purely a description. This is like purely schema, purely type information. So there's got to be some definition of the function somewhere else. So let's look in easy resto test. Okay, let's keep looking here. We got allowed methods. Okay, post. Wow, this is cool. Whatever this thing is going on in GitLab, like, I didn't know they had like IntelliSense for. Whoa. Oh, this is legit. Oh, and okay, so what is this actually doing? Saying, oh gosh, what is this? Oh, this is just the LWT bind, I think. It's saying allowed methods. Sure. Go to definition. Sure, we're in each directory. Register describe directories. Ooh. Registering. What does registering do? Resto directory? No, this isn't what I want. Okay. No. What we need is new window. We're gonna connect to no. We're gonna wait a minute. New window using Ubuntu. Instantaneous. Open folder. Repos. Resto. All right. Now we're gonna run. No. Okay. opam install. Oh, I hope this works. Camel LSP server. Yes. Okay. Then we might have to run dude build first. Let's see. No. We don't have any type information. Hey, I recognize these people. We're gonna run eval opam env and we're gonna run dune build check. What do you what? I ran opam install dot. Right. Build check. Dune external lib deps missing at check. Okay. Maybe this is for like the tests. I bet it's for the tests. Okay, and then we're gonna start the language server. Hey, we have type information. All right, test. Easy services, easy resto test. .ml. Okay, where's our ad service? Is there anyone in Gather maybe can help me? Oh, I have. Yeah, that's fine. No, it's not. There's got to be some kind of something. JSON. Oh, this is looking promising. Right. There's Oh my goodness. All right, without okay, dear viewer, let's talk about the problem we're trying to solve. I thought I was going to be clever and make a helpful video about how RPC works. But instead, a video about not understanding how RPC works. So our problem, rubber duck mode, activate. Our problem is I'm working on a new client command. Oh, and this command is calling a contract. And the contract it's calling is a local one right here. So we're going to go to FAQ to remember how to call this contract. And it goes something like this. And we're going to replace it actually with mockup client. Run script. Let's see what our options are. Okay. Run script source on storage and input blah blah. All right. Run script mockup client run script C on storage. I think it's so we give it an integer storage and then it gives us back an integer, hopefully. And input just can be unit. Great. All right, this is looking pretty. All right, wait, let's get rid and let's start the build watching. All right, so the error is this value is invalid for type int. Expected primitive. Only an int used here. Well, only dot star can be used here is here and actually unexpected primitive, so it must be unexpected primitive comma, so it's got to be this one. Right. So this is in Michelson v1 error reporter. So obviously what's happening is if we what's happening is running the contract and it's going through all of this stuff. It prints before run and then it tries to run it and this result right here is an error and then it prints the result. So what I'd like to do is I'd like to modify the function that type checks this thing. Functions such that it type checks the fully substituted contract. So let's dive into run. Now the first thing that we hit This should be okay. How did that work? What I'm wondering is, all right, so we pass in this script command here. Or if the error message, like, is the error happening here? Is it happening somewhere else? Expanded script. But the thing is, I've already modified the encoding of script expert, so I know for certain that it does parse. And it's not a parsing error that we're getting, it's a type checking error. So that's fine. So this is all valid. This is chaining together the error monad right here, and this thing is returning error. And I want to fix that. Problem is, like, as soon as I dive in, we're already in this run code thing. So run code. This is a bunch of arguments, right? Block. What is this? Oh, it's like some kind of wrapper around the alpha context. An RPC context. That makes a lot of sense. Okay. RPC context make call. We're going to have to dive into this make call thing. Because when we go to run code, this is just like a, schema of what the input and output will be, but not the function for deriving the output. So yeah, this is a dead end, which means that, let's hit Control O, back to that run. All right. Oh, going back here. There must be some kind of dynamic dispatch here. There must be. I'm like really surprised this isn't some kind of GADT, to be honest, but that might be nightmarish to work with. Not saying there should be a GADT, and go to definition doesn't work. So what we're going to do is we're going to search for make call 0, and we have it in the environment. Let's go to v2 because I confirmed today that it is v2 that works from. How does this work? Okay, so it's a wrapper. What does make call 1? All right. We're learning the O in OCaml tonight. Object layer. All right. Call proto service 0 method. Oh boy. Epic environment. Oh, okay. This is just the type. Okay. All right. Where is the implement? This is the most boring video in the whole world. I'm sorry, audience. I really wanted better for you. Ooh, and I am coming up on time. Hey, wait a second. This looks like an implementation. Method. Equals. Okay. 1, 2, 3, 4 arguments. Here's argument 1, 2, 3, 4. Look up call service. What is Q? I. Input. Query string. Okay. The block. The query string. The input. The output. Gotta be clever to work it on Tezos. Our context equals convert the block, some RPC context, and then call the service. Call service S, RPC context, this query string, and an input, and I will return you the output. This is exciting. What is call service? Call service. Narrow down our results here. Okay. Method. Call service. Oh, how does this work? Call service. 3. Okay. The other place. Call. Okay. I take in for all types M E query string input output method. M stands for method. P stands for path. For a method, a path, query string, input and output. Oh man, it's getting late, but I'm pumped up. But I think directory means something different in this context, like other than like file directory. All right, look up. Sure. Wait, what the heck? Oh no, I'm looking in the wrong place. Dang it. This. How am I missing these things? What file is this? Client, Resto. Oh. Oh. I'm in OPAM, which is apparently excluded from my VS Code search because it's not like it's not in like it's in git ignore. Oh boy. Tight service params query body. Where is it implemented and how can I test this? Maybe I've gone astray. Maybe I should have gone back to this. Like int. Let's look for add. I think directory means something very different than perhaps what I thought it meant. Because look at this. Register one, dir, add service. And then here's my I plus j. This is where add service is implemented. So can we like find all usages of dir? So yeah, if I change this, like, I minus j, I'm gonna fail right here. Okay. So somewhere there's a function called where's this register one? Register one is in the Resto directory. Interesting. Okay. I want to like complain or ask a question here. Like, hey, what does directory mean? Or like, could we document what it means for like, posterity? But that's not really useful. Like the useful thing to do, figure it out, set an MR with some new doc strings, then we'll move on from there. It will be good and I will have learned. And that is the point of this stream. Learning, not complaining. I think I passed over it all along. Easy directory. So I think the directory is what in Node.js parlance would be called like a handler, like a request directory request handler. Or one. What's the difference between register 2 and register 1? I has doc strings. Now I feel dumb because I should have looked if the doc strings were there in the first place. Register, period for specific entities. All right, register. DSH is a directory that contains all the services registered in deep. All right, what is a directory? A set of services on which requests be dispatched. What is a service? Pray tell. Directories are sets of services. They're used to spin up servers. See, server. All right. Oh, this is where I should have started. The server. Like, there's gotta be online documentation for that. Oh, server.mli. When they say C server, they mean like look at the types. We're gonna do that. Like, what is a server? Right. Let's go back to directory. Set of easy resto directory. Server. We are in easy directory. This is what I wanted. This is what I wanted. Ah. Is there a resto? This has more pros. We're going back to this. Easy resto is an abstraction layer on top. It's simpler to use. Recommend that you read the documentation. Blah, blah, blah. Describing services. So question, are we using the easy resto interface or the resto? Oh, please, Lord, let it be the easy resto. Okay, easy.star resto. No? That's too bad. What if I do include underscore opam? No? I tried. You know what? We're going to read the documentation anyway because it's a good starting point. Oh, okay. Getting close, guys. By close, I mean we're making progress. For example, you can use the directory of services as a whole. Forms the API for what? One of the other Resto server. Okay. So this splits out. Okay, so this is kind of interesting. My intuition, right? Or is it run service? Run code. This corresponds to the first sentence. It's a directory. Like this whole thing is this plugin.ml. It's forming a directory, a set of services. This is a single post service. And this is the description of the inputs, outputs. Okay. And this can be used, according to this first sentence, to implement a server. Okay. Then client. So I already know where the client is implemented. That is literally the Tezos client. Now the question is, where's the server implemented? Lightweight version. Note that whilst the interface is lightweight, actual runtime cost is the same. Very nice. Yes, like, yeah. Okay, intended use. As follows, define arguments. Define services that use in the previously defined argument. Running a server, you can then use easy Resto directory, register the service, or you use the, I wonder if these are like disjunctive, mutually exclusive, like XOR or just OR. Resto co PP server. What is this? Lib RPC HTTP. Patch. Register. Register. Register conflict. Ah. Service. Nice. Got register. Okay. Register 0. All right. Register 0 should be some kind of like what? Fmap, I guess. All right, so it takes in a directory. What is a directory again? What is a directory actually? Static? I lost it. Okay, directories are sets of services. But the way it's implemented, it's, what am I doing? Where's the directory type? Init directory. It's a set of services and subdirectories. So it's just like, we're gonna ignore them. We got it. It's a set of directories. I'm sorry, no, it's a directory is a set of services. What I meant to say. Directory is a set of services. Got it. Okay. So this register function should be a glorified like map, like, you know, I arrow O modulo LWT, whatever. Register. Okay. We take in a set of services. Oh, nice. Okay. So this is like, consing onto the set of services. And you can have an empty set. So you take the set, and then you take a service. Ah, here it is. And then you take a function that accepts params, queries, input, and it gives you an output result, or the promise for one. and then you get a new directory. Oh, okay. Okay. Making some progress. So what we're looking for, wait, how is this curried? Register 0, specific ready of services. Like, how is register 0 implemented? What does currying do? Oh, so currying is, I think it's taking, like, I'm kind of confused because of Lisp. Like, okay, so currying, curry is just taking a function that accepts like 3 parameters and returning like a function that accepts 1 parameter. Then you apply a function and it returns a function that takes like the 2nd parameter, and then you apply a function that takes the 3rd parameter. Like, it's confusing because OCaml is already curried. So like it's auto curried. And it's represented in the types by like, you can't just write, you have to write A arrow B arrow C. So what does this do? Oh, this must be, register. So what is the type of register? Takes a directory, a service, a thing, and returns a new directory. And register 0, query takes. Is this like a built-in? Is this like operating on like pairs and stuff? I think this is some GADT stuff. Yes. Yes. Okay. So the reason you need curry, like I'm a little fuzzy on this, like, so quiz me on it. But I get the gist. The reason that you need curry here is not because OCaml doesn't automatically curry functions, it does, but because we're not currying, I don't think we're currying like you can't auto curry GADT like pairs. Pairs are not auto curried. So we're like working at the type like we need to transform function so we have a function and a tuple. Yeah, a tuple of the parameters of that thing. And now we want to transform the function into a curried function so you can apply the things one at a time. Did I say that right? Yeah, so you can iterate down your arguments by it. Okay. That's a terrible explanation. I think I have the gist, but as I just proved, I'm not so sure. So We're gonna move on. Register 1, register 0. Go back to register because I liked register. Register 0. All right. Let's go to them. We're taking in a directory, a service, function that gives you the answer, and we're returning a new directory. So the real question is, there it is. I need some water. I wonder if I'm muted while I'm in BRB mode. I don't know. Find out. Anyway, back to the show. We're not calling it a show, we're calling it a stream because the idea is active participation. But this one's going to be uploaded, so it is more of a show. Register 0. The P2P. All right, let's take what we let's review what we know. Okay. Where did my terminal go? Whatever. We're running the client in mockup mode. Mockup mode is this really cool thing where you don't have to run a whole node to do commands. Now, the hope that mockup mode is small. Hope is that this is smaller than like the whole, the whole node, and that find what's going on. So, and also to review, we're looking for the run code thing. Okay, so run code is defined in lib plugin. Now, I'm beginning to wonder, what is, like, there's no docs or anything in lib plugin, but and I was wondering, like, what is the purpose of it? But I wonder if it's so you can like abstract away operations to be implemented in like mockup mode and non-mockup mode and etc. Which, with what we've learned from reading the Resto documentation, like it makes sense. This is the specification for a thing, and then the thing is going to be implemented in like potentially multiple places. So if we go to plugin register, I was hoping this would be helpful, but I don't know what a pre-validator filters is. Like, this might be a bad rabbit hole. Where are we? In lib. We're in lib shell. We're gonna hope that we don't have to go there for a second. Okay, so anyway, run code. So all right, where is run code used? Okay, what we're trying to find is like somewhere this service is going to get bundled up into a directory. And then somebody's going to call register on that directory. And they're going to have like the implementation, like a function that gives the answer. So we're getting real close. Where is run code used? This is why I wish I had my code search tool that I want to build someday so we could just like ask a database like where's run code used, but that'll be for another stream. Run code, this is like I don't. Okay, so there's no MLI file, so this is the thing itself. This is both the implementation and the interface, which is fine, I think. Especially because you can have. Not get distracted here. So it's in this scripts.s thing, right? So like let's search for s dot run code, and sure enough, oh, right there all along. Plot twist. All right, so we're gonna scratch what I said about plugin registering. Sorry, like the lib plugin being some kind of abstract interface for mockup client and node, because this implements it. What a plot twist. What else is in here? Uh, oh. Okay. Wow, this is weird. This is weird. What's going on here? All right. So make call, we're gonna assume is like client code. Like you know, curl this particular thing. Okay. And this is like a wrapper around curl. And it's a wrapper specifically around the run code endpoint. Now, before you call register, kind of interesting. Like, I don't think you can do. Wait a second. They say that it's type safe. How can this be type safe? Because like until you call register, which is a side effecting function. Oh, it's an RPC service. Whoa. Like, I feel like I'm playing Twister and losing, but on the inside of my brain. Right. Okay, focus, Daniel. You can do this. So, run code. All right, we got to figure out what this context is. It's a environment RPC context. That's simple. Well, at least it's the simple one. All right. Wish I could go to type definition, but I can't, and this is why I need to learn Emacs. That's going to be next week's problem. This. All right, let's do module RPC context. Yeah? Boom, got him. All right, so in RPC context, wait, this is like, wait a second. Context.t, like, is this like econ? This docs. Nope. So many rabbit trails. All right, where were we? Because we were making progress. So we're in libplugin. We take in a context. It's really, oh, I don't think that's even the same context that looks really different. All right. This doesn't look type safe to me because I think I'm using JavaScript brain or TypeScript brain to like read this. I think you can make it type safe by using GADTs, like abstract away the types and then like instantiate this function with like what previous things you would have had. Like basically the only way to call, like invoke this function is with a value that the OCaml compiler can prove that register, like register was called on. Or let's see, wait, that's not right because this is unit to unit. Forget everything I just said. I'm so confused. Maybe it's not type safe. Or maybe there's some kind of dynamic dispatch. Like I don't actually understand the OCaml like the OCaml's object system. Read the docs on it like last week, but apparently that wasn't enough because I'm so confused. So I'm just gonna hope that it's okay. Because I'm running out of time. Like we're just gonna make some wild guesses around what RPC context does. All right, make call. Let's work with the assumption that this is like curl, and this is like the path plus like the schema. We're passing this thing into curl, and then here we're kind of like packaging up our arguments, you know, that we're gonna post to our HTTP endpoint. So yeah, I'm really confused because Resto said like this is like the type safe thing, but how do you know that this is being called on something that has already been registered if register is just like a side effect? Super confused. Someone's gonna have to explain that to me, but we've found our implementation and it's right here. This is the code that I wanted to see. And if we print line, print end line, ta-da, and oh, yeah, oh, look at all this stuff. Whoops. Yeah, okay. What's your problem? Wait, what? This is so messed up. But let's see. Gotta get rid of that. Like, how did I get this? How did this error message come from a not being able to build? This was working before, but try it. It's still the same thing, actually. Very weird. I got it. I got it. I got it. I got it. Apparently, you have to run it in the correct directory, which is weird. Oh, you know what? You know what? It did a test. Oh, wow, I feel really dumb for associating this build error with the thing just because the two were close to each other in time, but whatever. Live and learn, right? Um, so I think that this did some kind of test, like, hey, does the file test contract constants.tz exist in in the current directory? And it said no, it doesn't exist. So let's try to interpret it as Mickelson. And like, is that reasonable behavior? I think it's reasonable behavior. Like, yeah. Like it'd be kind of nice to like put it behind a switch. Whatever. Nitpicking, I figured it out. Okay. Not for type int. Right. Okay. So what we're trying to do is we're trying to see, is our error message printed? And yes, it is. Ta-da is printed. So if we look up and if we go like way down to the end of this function, like execute right here. Wow, this is actually really cool. Because like viewer, this is kind of hard to figure out. Like how to use the interpreter in like the script interpreter.execute. Like it's a little complicated. It took me a long time. I think because like inside apply.ml, interpreter execute. Yeah, like right here, there's just like a lot going on in script interpreter in apply.ml. But this is like the canonical place where you interpret scripts. Like so being able to see like For testing purposes? Oh, like all I have to do is originate a dummy contract and then like define some payers and storage and stuff and then call this thing and I get the new storage, the operations, and then like any lazy storage diffs, which is like big maps, big map differences. Like this is pretty nifty, actually. This is a good reference. Um, Actually, you know what? Just for posterity, um, like we're gonna add this to like, I don't know. I guess, I guess we can put it in the FAQ. Why not? That's what it's for. I've certainly asked, how do I use the interpreter? Many times, so I think it qualifies. We're gonna go here, and we're gonna, uh, and we're gonna say back. I need help calling script interpreter dot. I need I need help like invoking Michelson contracts, expecting the output storage, operations, etc. Look at the unit tests. Let's find these suckers. Let's go to. Actually, I think it's so. That means. Oops, that means that it's right here. Um, like test maybe interpretation. Run script. Look at this. Man, so cool. Okay, so you can go to. Is there like a open file on remote? Too good to be true. Oh, because it's my branch. Let's do master. Beautiful. Beautiful. Okay. You can look at the unit tests in source proto alpha lib protocol slash test slash unit, i.e. this module. You can also, and this is the new thing that we learned, look at source proto alpha lib plugin.ml, specifically the in 2 layers. So what? Wait a second. What? Oh no. Come on. RPC. Right, RPC. Specifically the RPC dot register function registers the code and is a good example of calling interpreter. And like, how do I like post this bit of nuggety wisdom to my friends at Marigold? Um, Cool. Okay. Guys, I'm excited about this stream. I feel like I'm learning lots already. Thank you for being part of it. All right, so our hypothesis is that this message right here is never going to be called because it's going to fail in the parsing, like somewhere here or before, somewhere. We're going to find out. Test those hypotheses. We're wrong. And the reason we're wrong is because I'm forgetting what script execute does. I'm probably confusing it with the like the step function, which is what I use most of the time. So what does this do? This takes a script.t, which is like the like it's kind of like it's the Michelin representation of a script, which you can kind of think of it as like raw JSON. So this is the untyped representation. So that means that execute is calling the typer, and the typer is not getting called before this, which is good. Like I wasn't sure. It's like maybe somewhere in here we were typing the code as well. But now I know. So if we dive into, oh, you know what? Let's get rid of and maybe ta-da, plugin. Just because this was called. Wait a second. Is that true? Like, I would really think that we would type scripts before we originate them. So the problem I'm trying to solve is I've added some new constructs to Michelson language. Michelson is written in Michelin, so it's like you know like not like Lisp because Lisp is too flexible. It's like we've programmed our own language, or we've made our own language out of JSON. And Michelson is the valid subset of that JSON. And then Michelin is the whole thing. And a script.t, aka a script expert.t, is just JSON. And then internally, we have a typed intermediate representation. And so what I've done is I've added like the new constructs to like the JSON schema, if you will. But I haven't added them to the typed IR, and we don't want to add them to the typed IR. So every time we call, like the type function, like every time we tell Tezos like type this contract, we need to first call substitute. And I probably should have started with that in this recording, but we need to like substitute all of the constants for the values that they represent. And yeah, we're just trying to find everywhere that this is called. And now it's really clear to me that like, all right, the valid path forward would be, well, we probably generate like, see, I don't want to make assumptions. Like the problem I'm having is, where is this error generated? No idea. there's no stack trace because LWT eats it. So like I'm guessing now that like the error is generated in script.ir translator, which, as the name suggests, is the place where we translate scripts into their typed IR. And honestly, like that would have been better if I just started here. I could have saved myself like many hours at this point, probably like 3 or 4. But that's okay because in the process of doing debugging, we've learned some things. Now I'm assuming that I've figured it out when I haven't actually. So you know what? We're gonna wrap this up and we're gonna put a bow on it. We're gonna review everything that we've learned. This will probably be what's more useful to people. So let's do it. Okay. Let's start from the top. We want to add a new client command to Tezos that our lovely users can do something new and cool. Where we do that is in lib client commands. Let's see, lib client commands. Like this is where all kinds of different commands are defined, and basically, you add them to this giant list of commands. And this syntax here is using the click library, written by Nomadic Labs. You can look it up. And basically, it's pretty simple. You take, you define some like data types for the arguments. And like they include, it includes like combinators for, parsing these things, et cetera, et cetera. And then it's got like this prefix combinator so you can make it look nice and pretty. And, takes, if you want to add like positional parameters, you do this param thing. And this like at operator here is like the, so like it's best if we just show an example. So here we can, we can easily map what's going on. So we've got like run script is the prefix for this thing. Like this, source parameter. Oh, I'm showing you the wrong, no, I'm showing you the right thing. So yeah, run script is the prefix for this source parameter, and then on storage, and then you give parameter here. Like, see how this is a positional parameter right here? It took me to figure that out. And then here's data parameter, so blah, blah, blah. And if we just look at like, okay, how is data parameter defined? Well, it's like this click argument combinator or whatever. I guess, I don't know if it's a combinator or a data type. I guess it's a data type because it's a like data, not transformation on it, but I don't know. Anyway, you give doc strings and then like go to data parameter. Here's the function where like you take in what click gives you, which is like a string, and you parse it into something that the protocol can better understand. So if you were going to add it, you'd hopefully, check these and see if any of them fit the bill. They probably do. There's a lot here that you can reuse, but you might need to implement the others, and it's not too hard if you follow the examples. And so if we go back, yeah, so then, it gives you all of the parsed arguments, which is really nice in like this giant tuple. All these ones are like all the ones in this giant tuple are the actually like the switches and flags and stuff that you put here in this like args9 thing. And then the positional parameters each become, a positional parameter in the function. And then you can do your thing. And the way the module is set up is in this same file. No, in a different file. See, we were in libclient commands. It's actually in libclient that that the like implementation usually sits. And I don't know why they're separated, but they are. And so like I think the structure is something like bin client depends on libclient commands, which depends on libclient. So, and they, libclient and libclient commands live in lib protocol, which is, like the proto alpha. I said lib protocol. I meant they live in proto alpha. So, they change from protocol to protocol. And yeah, so you're going to go into libclient and you're going to implement the thing. So in our case, we've got like register global constant. Like in this libclient thing, this is the function that injects a manager operation. So we've built the client, and like click handles all of the stuff, and it bundles all the arguments that the user gives, it delivers them to your function inside libclient, and then in libclient you have access to this like environment, like this client. I don't really understand what this is, to be honest. Like it's the client's version of the context, with which you can do like you can inject a manager operation. And what's nice about that is by the time you're in inject manager operation, like then you're like you'll be dropped straight into apply, and you'll be dropped straight into apply, and from there you're back in the protocol, which if you're like me and started in the protocol, you understand. We also learned about RPC, but it's getting late, so we'll talk about RPC today. Watching.